Hello everyone and welcome again to another video tutorial on how to perform motion simulations on NX11. So we're going to be working on this. So this is a marble machine, and I do apologize, I need to make this slightly quick, few reasons. I just recorded this video literally an hour ago and it was about 27 minutes long, and it wouldn't let me edit it because it was too big of a file. And this is part of my project, my dissertation, and that is due in about 14 hours, so I need to hurry up and get this done. So this is probably going to be up 15 minutes, and I'm sorry if I skip over parts, but it has to happen. So yeah, as I said, we're going to be working on this and we're going to try and simulate this ball rolling down the ramp, up the gear, and well, essentially just looping. But we're going to do some interesting things that you'll see. So I'm just going to quickly go to motion environment. So watch the first video, then have to actually do the basics. I won't be going through over many of the things I talked about in the first video, so like sort of the links and joints. So in the end, we're trying to hope to get something like this. Yeah, whoa. So, and then there you go. So that's what I mean. We're going to create a sensor in quotation marks. So as the ball hits that, it's going to rotate in the other direction. Sorry, let me grab this. Okay, yeah, so let's just close this. So I'm just going to create a new simulation here. Okay, let's just save the changes, why not? Dynamics, we want a motor driver recurdyne solutions option here because it's going to allow us to use the PMDC motor and signal chart, as you'll see later on. I won't name anything, but feel free to give your simulation a name. So motion one, first I'm going to create the links. Actually, before I do that, I'm going to press Control W and get rid of sort of the datum planes, and I'm gonna, that's pretty much it for this, and then I'm gonna press W, and that's to get rid of this. That's how you get rid of that. And so what I'm gonna do is create a link, and first I'm just gonna define the solid body of the helical track, and it's gonna be fixed. I did this earlier, but it wasn't working, but we'll see, we'll try again. And then I'm gonna make this sort of motor one, because it's made up of multiple different parts. So I'm just going to make that as kind of one body. I'm going to fix that as well. So essentially, I'm going to make this mechanism is going to give the illusion that this motor is driving this gear, which drives this gear, and then it makes it revolve, kind of thing. So that's the effect I'm going for. That's what we're going to use, kind of these options up there. So what are the links have I created? I've created this and this. So obviously we need to create the link for the smaller gear, and we don't want it to be fixed, so we're going to untick that, apply it to that one. These four, so these are the rails which are going to hold the ball back, and I'm going to actually fix this one, and then the ball, we're going to not fix that. Okay, fantastic. Actually, let me go back to this gear, this, and then just to make sure this is all kind of done. Okay, because it was giving me problems earlier in the previous video. Joints, we're going to quickly create joints. It says these are fixed. Okay, we'll just assume they are. We're going to obviously give the big gear a revolute joint, so we're going to use the trick from the first video. Oh, sorry, there we go. So as you can see, it's selected the link, origin, and also the vector, which is normal to the plane of the spinning gear. And we're going to quickly apply to that. This one, yep, we're going to kind of do the same thing. We're going to select the edge in the large gear, and so selected the gear link, the origin, and the vector as well. As you can see, the vector doesn't really matter, to be honest. But what we're actually going to do, we're going to snap it, and we're going to do that, so it kind of stays in that orientation there, and then click apply. And let's have a look at the joints. So we've got two revolute joints. I think that was it pretty much. I don't think there's anything else. What I'm actually going to do is I'm going to go back to the joint 2, and I'm going to give it a driver. So I'm going to give it a polynomial function and give it a velocity of 360, so 1 revolution a second. Oh, select the link. Sorry, sometimes this happens, just I don't know why it does that. Just select the link again, and as you can see, now we've got driver link. Again, I'm sorry I'm going through this quite quick, but this is quite basic so far. Okay, let's just work with that. So as you can see, now it's got driver attached to it. So next we're just going to quickly define all the 3D contacts between the ball and well, pretty much everything. So the ball's obviously going to interact with the track. So let's do that. Let's do apply, and okay, it's letting us do it again. Let's just do that. Okay, duplicate joints. Okay, so it's really not letting us do that. How very stupid of me. Okay, let's just do that and that. So it's obviously the ball and the track. And what's annoying is it only does bodies and not the links. That's why it won't actually let me do these kind of as one. So that's sort of a downside to this. It does increase the solve time, unfortunately. And I think that's pretty much it. So we have 3D contact joints between, well, essentially everything. Well, except for these, because it's obviously not going to be in contact with them. That's 3D contact. And now, okay, this is we actually want the PMDC motor and the signal chart. So make sure you solve what is on the Recurdyne option. And I think, yeah, I don't know why it did this earlier as well. I thought I made a mistake, but just make sure it's on the motor driver here. Click OK, and then there you go, it comes up. So we're going to define the motor, and I'm looking at my notes here, and it was 1.2 volts with the other one. I'm not going to pretend like I know what all of this means. I am not an electrical engineer, even though I did do an electronics module, but I didn't do too well in that. So yeah, you probably know more than me, so you can mess around with all of this, but all I know is that this 1.2 volts works for me. So I'm just going to click OK, and there you go, as you can see, that's my motor. So that's kind of acting as this. These options, I should mention that pretty much all of these options, they don't actually create the physical, you should know this, but they don't actually create the physical kind of component. They only create the effect of that component. So like the spring doesn't create a spring, it creates the effect of a spring, and it denotes it by a symbol, so it lets you know that it's actually there. And it goes for pretty much everything else. Like the gear option doesn't actually like create 3D contacts between all the joints. It only once you define the we'll come on to that, but it actually only defines, like, so this gear is 4 times larger than this one, so it's a ratio of what, 4 to 1 or 1 to 4, and so that's what you essentially put in, and that's what drives it. It just gives the illusion that it's driving it. You can actually use the 3D contact option to actually drive gears. Obviously it takes more time to solve, but that's what that option is there for. Signal charts, this is our next thing. This is what we need. So there's 2 options. We're going to go with a closed loop for this one, and I'm just gonna, okay, so the initial signal value is going to be 1. So this is, you can think of this kind of a binary. Instead of 1 and 0, it's going to be 1 and -1, where, well, I'll come on to it. So let's just create a new event. And so in the event setting, there's 2 options, absolute time and timer. There is a really good video on YouTube by CAD-IR Cam Tutorials. I think he's an Indonesian or Malaysian YouTuber. You've probably seen his videos, and he has a really good video on the PMDC motor and this sort of stuff, talking about, he uses the absolute time option, where he drives I think it's a printer scanner, so the head, so it moves it towards the end, and once it hits the end, it moves it back. So there's a really good video on that. I'd recommend that, but I'm going to use a timer for this. And so the time delay is going to be 11 seconds, and it's going to be signal of -1, and then add. And so I'm just going to quickly just put these in, because obviously I've done this before, and I'll just explain what I've done. Okay, so what I've done is, so what this means is, rather, so with a initial value of 1, after 11 seconds, it's going to reverse the signal. And so what it will actually do is reverse the direction of the gear, as you saw in the first example. But then after another 11 seconds after that, it's going to reverse the signal back to 1, and so it's going to go back the other way, and so and then it carries on doing that. And so you can have as many as you want. Obviously it's only limited by the length of your solution, but yeah, that's pretty much what it's for. It only kind of reverses direction kind of thing. Yeah, so I guess I'll just move on from that. I kind of want to make this 15 minutes. I'm trying to be quite quick here. So there you go, there's a signal chart, we have a motor. One thing we do need is the driver option. So the driver option, although we have defined a driver here, is the way you can think of this. So this driver here rotates the gear, which rotates this wheel, but then the PMDC motor drives, oh sorry, what did I do? Sorry, controls like that. The PMDC motor drives this joint, and then the signal chart drives the PMDC motor. So technically, the signal chart drives everything. as you see, so if I go to the driver option here and I select this joint, so I want to drive this joint using the motor option here, so using the motor option here, and since we only have one of each, it only selects those. That's why you have to have both of these in order to actually create a sort of like a DC motor kind of driver. And this is the only option, unfortunately. There isn't, you can't use like a stepper motor or like an AC motor or any of that sort of stuff. Unfortunately, that is one limitation of this feature. And so what this means is, yeah, I've pretty much said it, I think. So this signal chart is going to drive the DC motor, which is going to drive the joint. So the actual speed of the rotation of the joint, so the angular velocity of the joint actually won't change, pretty much. It's only going to reverse the direction, as you'll see. So there you go, there's our driving container. And anything else? Oh yeah, of course, we need to define the sort of relative motion of the gears. So this didn't work earlier. Yeah, that's not why it doesn't work. Okay, so we're just going to use a 2-3 joint coupler, and so we're going to go like this and like this. And so it's a scale of 4 to 1. So the first joint is this, as I mentioned in the beginning, this gear is 4 times larger than this one. I can't remember the dimensions, I really can't. But yeah, so, and as you can see, I didn't create it, but we'll see in the other one. Normally when you use the gear option, it creates a symbol for the joint gear essentially. And where is our coupler? There it is. As you can see here, this 0.25 here, that was it saved the original value from the one I did initially. I really don't know why it's not working. I think it's because it can't be a driver, but yeah, don't hold me accountable for that. I'm going to click cancel, and that's pretty much everything for this. And obviously we need a solution, so let's create a solution. It needs to be a normal run, of course, but then the important thing is it needs to be control dynamics, because this is control here. So obviously we're using this to essentially drive our mechanism. So this is really only to drive mechanisms essentially. So we want this option. The time 37 seconds, simply because I've done this before and this is what works best. You can change the number of steps. So I think if you increase the steps, it decreases the time of the simulation, so it makes it more accurate to real life. I think the optimal ratio between these is I think it's like maybe 1 to 1,000. I think that's the optimal one. So that's one way to know. I think if I go solver, yeah, just make sure the step size is the ratio. Yeah, so 0.01 is that 1,000. Maybe it's 1 to 1. My mind isn't working. It's 2:18 AM at the moment, and I need to get this done. Just make sure this ratio holds for this, but obviously for it to look real essentially. But obviously I'm waiting for this one, so I'm just going to get rid of that and okay. I think that's pretty much everything. I'm going to hit solve, but I won't solve all of it, as you'll see, because this will take probably 5 to 10 minutes, and I do not have the. Okay, so what this is telling me, because this is going so quick. Okay, I can see the problem already. These it happened earlier as well. These links have lost their fixed joints, so we're going to quickly go to here and define all the fixed joints in this mechanism. And vector doesn't really matter, it's just apply, and as well as fix that. Just gonna apply. I think I need to fix this as well, and I think that's it. Let's just double check something. Okay, can't do it again, can I? Alright, whatever, let's just keep adding fixed joints. I'm just making sure everything is fixed. Okay, now if I solve it, I think it should be quite a while. While it's solving, actually, I should mention that here, as you can see, this solution has it's sort of got like a battery symbol kind of to it. That's what denotes it's in the control/dynamics solution type option. And as you can see, it's taking forever. So which means it is working. So this should work, but obviously I'm not gonna wait this whole time. So I'm just gonna exit this. Okay, yeah, it's come up with redundant constraint. I think I did way too many fixed joints. Let's just delete this. All right, whatever. So let's just, okay, let's hot solve again. My fan is going crazy. Okay, yeah, okay, there you go. So now this will take a couple of minutes, so I'm not going to wait that long. So we're going to abort that, and we're going to go to this one, and I've already previously solved, so as you saw in the beginning. And so this is what it should look like once it's done. So it hits it, and then it reverses. So essentially we're creating the illusion of a sensor. That's what that is. This is what all of this is for, kind of. So if you want to simulate some kind of, because it's very difficult to do it mechanically. You can, obviously, with 3D contacts and all that sort of stuff, but why complicate your life when you can just use this? It really just, it does the same thing, kind of thing. It's only for proof of concept, really. I should mention, if you ever do something like this, normally on the, let's just let it go around a bit, and then, okay, I'm gonna pause it there. I'm gonna skip. You'll see this. See how it bounces back. You see this may occur to you in your simulation, so just be wary of that. I think just reduce the speed of the rotation, and that should solve it. And as you can see, the actual holes are slanted. This is so that the ball doesn't fall out when it's at the bottom, and then when it gets to the top, it's sort of upside down, and it allows it to roll out. And so that's what the rails are for, is to prevent it from slipping out prematurely. So yeah, I think this is 16:25. I need to hurry up. Anything else? Anything else? I think that's pretty much it. Yeah. Okay. Yeah. I'll just wrap up, I guess. There is. I didn't talk about. I kind of wanted to talk about how to gather data, but that will have to be for a future video. I only have to create 2 videos for my sort of dissertation, which is the first one in this video. Hopefully when it gets uploaded in the next few hours, because it needs to happen. So I'm not sure when I will make a next. If you have any requests, please do put it down in the comments. I will try and make a video on it. But obviously I have exams coming up and all that. So, and as I've secured a placement, I'll be going on placement next year. If I have free time, and access to NX, I will try and create more videos in my free time. That is the plan. I can't make any promises, but yeah, I will see what happens. So yeah, thank you for watching. I need to quickly edit this and just get it uploaded, because this deadline is fast approaching, and yeah, I'm probably gonna have. Okay, just shut up and just end this. Okay, thank you for watching, and maybe see you next time. Thanks.